Hi everyone, and welcome to this series of PEO Electrical B7 Power System Engineering exam. And this is a question from the exam of May 2023, and it has three parts. So basically, I will be solving part one, and then part two, and part three. Now, I just want to remind you something very important, that three-phase questions are basically a must question. So you don't have the luxury to choose not to solve it. So it's very important to understand it, especially it is really easy. And this question is combining between balanced and unbalanced system, as we will see. So let's start this question. So it says here we have a balanced four-wire. So as you can see, this is a four-wire Y-connected system. Has a line-to-line voltage 416. So the line-to-line voltage here is 4160 volt. So that is the line-to-line voltage. And assume VAN. So your VAN is your reference. It means it has the angle of 0. It supplies 4 kilowatt. So basically here the load is 4 kilowatt. And the power factor is 0.8 lagging. And the sequence is ABC as usual. Okay, and the neutral is grounded. Determine the following. The line current in phase B. So I want to find IB. So start with, as we know that the power in three phase is equal to √3 V line, I line, cosine theta, or the power factor. So from this, your I line, let's start with the magnitude, is equal to P divided by √3 V line times cosine theta, or the power factor. So your I line magnitude is basically equal to 4 times 10 to the power 3, 4 kilowatt, divided by √3 times VL, which is 4160 times 0.8. And this will give me a current equal to 0.694 amps. Okay, now we need to find the magnitude and the angle of phase B. Let's start with phase A because this is usually the default. Now, how to find the angle of the current? Now, since this is Y connection, then the line current and the phase current are the same. And I have to remind you something very important, that the power factor angle is the angle of the phase current minus the phase voltage. Okay, so basically your theta of the power factor is theta V minus theta I, and these are the phase quantities. Or it is theta Z, the angle of the phase impedance. It's all the same thing. So this is the power factor angle is equal to this. Now, since this is a Y connection, the line current and the phase currents are exactly the same. So there is no difference. So this is why we can say that your I line is equal to 0.694 minus cosine inverse of 0.8. And one will say why I said minus, because it is basically, as we, it's a lagging power factor. And it says here the VN is the reference. So your VN angle 0. So the current will have a minus angle of that. So it's equal to 0.694 angle of minus 36.9 amps. So that is the current. Now, that is the line current in phase A. I want to find phase B. So from this, your IB will be the same current because it's a balanced system. So it's 0.694. And the angle is minus 36.9 minus 120. And if it is phase C, plus 120. 0.6094 angle of minus 156.9 amps. And here this is because it's an ABC sequence. So phase B is minus 120 from phase A, and phase C is plus 120 or minus 240 from phase A. So that is the first part. Then the second part says find the impedance of each phase. So I want to find this Z. Okay, it's the same thing for everywhere because the balance system. So your Z is basically your phase voltage V divided by phase current. So the phase voltage, this voltage, V phase, divided by I phase. Now, the V phase is basically, this is the line-to-line voltage, and this is a Y connection. So it is 4160 divided by root 3 and angle 0 because that is our reference, divided by the current. The phase current and the line current are exactly the same. So divided by 0.694 angle of minus 36.9, and this will give me 3,460 angle of plus 36.9 ohms, or you can have it as a real and imaginary. So it's 2,768 plus J 2,076 ohms, and you will find that the angle here is the same as the power factor angle as I mentioned earlier. Okay, so that's the impedance of each phase. Part C, the magnitude of the current in the neutral. So as we know that we will have here IA plus IB plus IC. So the neutral current I from the big N to the small n is equal to IA plus IB plus IC. But because this is, as it mentioned, balanced system, so it is equal to 0, and you don't need to do any calculation. So this is part A. It will be followed by part C, so part B and part C soon.